So far, we've been working with monitor output, keyboard input, and so now we're going to take a little look at doing this using files instead. A text file, of course, is a software object that stores data on a permanent medium, such as a disk or a CD. Now, you may notice that if you run a program entirely from input data entered on the keyboard and view the output on the monitor, that the input data and the output data are no longer available after you've completed running the program. Being able to either enter data from a file or output data to a file can provide a tremendous benefit when compared to keyboard input. I have listed here a few of the main advantages of taking input data from a file. The set can be much larger, can be input much more quickly and with less chance of error. It can be used repeatedly with the same program or with different programs. And I would say one of that last point, of course, implies that once you have the data in a file format, it can be used over and over again, either as input to one or more programs, or various programs can either rewrite the file or perhaps append data to the file as new information is stored. Now, when you make a text file, or let's say you were to manually put together a text file, you would need to use a simple editor such as Notepad or TextEdit, gedit, in order to create, view, and save data in a text file. Right? So you can manually make a file. The important thing to realize is you don't want to use any kind of editor that adds, say, invisible formatting characters, extra column or new line data that you can either see or not see. That's a problem with, say, using Microsoft Office. So you would want to, if you did it manually, you'd want to stick to a very simple editor. And here's an example of what some data in an editor might, how it might look. All data output to or input from a text file must be string data. There's no such thing as writing a number to a file or being able to read in a number from a file. Notice that even with our keyboard input and our monitor output, it's exactly the same. This is consistent. All our keyboard input is accepted as text. So all file input will also be accepted as text. All of our monitor output is sent to the monitor as text, and that's the case of file output as well. Let's talk about writing text to a file. You can output data to a file using a file object. Now notice this is internal to the program. All right, basically what we do is we associate a file object or variable to the physical file on the actual physical media that we're writing to, say a hard drive. For example, we'll open a file for output, right? And in the process, we'll create a file. So we have the command F. It's a rather poor choice of variable name. I may go back and change that. F is assigned the value of open myfile.txt, W. So we see here an open function Notice, by the way, that that is a function. It's not being invoked on any object. In fact, it's being used to create the object f, which is the file in our program. And the first argument to the open command is the name that we're going to call the actual file. F is the virtual file in our program. My file text is the actual physical file that will reside on our hard drive, our flash drive, etc. Here we have the second argument, W. W means write. So we are opening a file for writing. And by the way, it's important to realize that every time you carry out an operation on a file, let's say you write to the file, when you want to read to it, you have to reopen the file. But that's just a little aside. We'll get to that later. So what happens as a result of this open function command? If the file does not exist already, it's created. If it already exists, Python opens it, and when you write the data to the file and the file's closed, any previously existing data in the file's erased. Right? So what we're saying when we write to a file is either we're creating a new file, and this is its name, or if this file already exists on your hard drive, your flash drive, whatever, if it already exists, then we're saying go ahead and overwrite any of the previously existing data on that file. One other note is that there's another argument we could replace the W with, and that's A. A stands for append. And append is a pretty handy way to handle a file. With append, if the file doesn't exist, it's created. However, if the file already exists, what append does is simply take the new data and append it to the previously existing data. It does not overwrite the previously existing data. So if you have already created a file and you've already written some data to it and you just want to add data to it, append is what you would want to use here instead of the W. But for new files, W is generally the way that we go. Now, once we open the file, once we actually create our virtual file in our program and give a name to the physical file on our media, we have to perform various operations. In this case, what we're concerned with doing is writing text to a file. And that would be through the write command. This is a method, not a function. Notice it's being called on the file object. f.write. And what are we writing? The argument, notice it's a string argument. The argument contains the string data that we will be writing to the file. Notice here we have one big string, first line, period. We have the escape sequence \n, which will insert a new line into the file. Second line, period, and again, \n will insert a new line. Now this is extraordinarily important, this line right here. The close method. So we created a file and opened it. We wrote to the file. Now we're going to close the file. And notice it's a method that is invoked on the file object. No arguments, right? If you don't close a file after you've opened it and written to it, it's possible that you will lose data. So you always have to close a file that you've opened. Now, how and why does this happen? Well, you might recall from the first week or so when we talked about the different parts of the computer, and we talked about the difference between RAM, which is our onboard memory, very fast, also quite expensive, and storage. Storage being, say, your hard drive, your flash drive, etc. Very cheap with respect to something like RAM, but much slower. Well, in order to write a piece of data to an external medium, relatively speaking, that is an extraordinarily slow operation. And if we waited for each little piece of data to be written, it would slow down the computer and we would get nothing done. So the general strategy, and this isn't just for Python, the general strategy is that when we have to write something for a file or get something from a file also, it works in the opposite direction. Every little bit of data that we want to write is actually written first to a cache area on the computer. And not until we get a block's worth, which is a fair amount of data, not until we get a block's worth of data do we actually do a block write to the output medium. I mean, you can almost think of it as these bytes are being poured into a dump truck, and when the dump truck gets full, it drives over and dumps its load all at once. This enables us to continue doing various things on the computer while this other operation is occurring in the background. And so it doesn't bring everything to a screeching halt. That's the upshot. The other side of this is that you may have, at the very end, after you've written all your data, you may have only half a load. And unless you direct it to be forcibly, dumped, so to speak, it'll just sit there, and then when your program ends, that data will be lost. So when you close the file, it forces that final read to occur, if it hasn't occurred already. And again, it only would occur on block boundaries. So it's highly unlikely. So don't forget to close your file. Notice this pattern. And this is, it just seems like for so many things that we've talked about this semester, we have this pattern of you kind of do something up front, and then you do the task, and then after you do the task, you have some maybe cleaning up or updating to do. We have that sort of issue with loops. Well, it's the same sort of thing here. We must always, when we work with files, first open the file, then process the information that we're writing to the file, and then close the file. All right, so remember that pattern. Let's talk about writing numbers to a file. Remember, the computer is expecting, or Python will write strings to the file, will write text to the file. And we don't write numeric data to the file just the same as we don't write numeric data to the monitor. The print statement always converts everything that we send to it, either because we've converted it beforehand or because we've used the comma argument. It will send all our data as a string. And so when we use the write method, it will expect a string as an argument. So our previous example, we just wrote words to the file, so that's no problem. But if you must write numeric data to a file, which is quite often the case, you have to convert it to a string before writing it to the output file. And we've done this sort of thing before. So here's a little example. We're going to generate and write 500 random numbers and write them to a file. So we have our import statement. By the way, since we're on the topic, I just want to note, you always put your import statements first, even before your initializations. So when you come to the coding portion of your program, please put the import statement first. It's not such an issue right now, but later on, when I say later on, actually fairly soon, we will be learning how to put together functions and other structures, and in that case it won't work properly unless you do it first. Alright, so we have our pattern. Open the file, right? Processing, and then close the file. So, open the file. We're going to create a virtual file that we call F, and F corresponds to this physical file, integers.txt, and we're opening the file for writing, which sort of implies that either we're going to overwrite what was there before or it's a brand new file. By the way, another important point is when your program runs, unless you have some other information in here, and we don't really need to deal with that this semester, where this is going to write the file is in the same folder as your program is running. Right? So you would expect to find this data in exactly the same folder that you placed your program. Here we have a for loop for count and range 500. You know that range 500 produces an expression, or a sequence, I should say, from 0 up to but not including 500. And so what are we doing with that? Every time through the loop, we're going to generate a random number using randint. And the random number will be a value between 1 and 500 inclusive. And then, now that we've produced the number, we can write it to the file. And please note these steps. We have to use the write method on the virtual file, right, on the file object. And inside, the argument is the number converted to a string, right? And notice here, we're concatenating a new line character. This is pretty common. In this case, since we have 500 numbers and we don't have any other data, you might as well just give them all a single line in the file. We'll see later that maybe we'll have a lot of data on a single line in a file and perhaps divide it by tabs. But it's very important that you divide it up somehow, because if we didn't have this new line character, the next number that got written, the next random number that got written to the file would be put exactly after the first number, and you wouldn't be able to tell where one number ended and the other began. So you have to put some kind of space, whether it's a new line character or a set of spaces or tabs or whatever, so that you can delineate the data in the file. And in this case, we're just doing the simple thing, one piece of data per line of file. Now, notice the end, we close the file. Right? We want to make sure that all 500 pieces of data actually get written to the file.